Hello. Today we're going to talk about free fall and how air resistance affects motion. So in your textbooks, you most frequently see situations that don't involve any air resistance. Why is this? Well, in this container, we have a feather and a penny. We can agree that they are affected by air resistance differently. If I take this container and I flip it vertically, you can hear the penny land and you can see the time it takes for the feather to make it down to the bottom. Newton's law of gravity states that objects fall at the same rate of 9.8 meters per second under the influence of gravity alone. This container is not under the influence of gravity alone. But what if we could put it under the influence of gravity alone? Here I have a vacuum pump that I'm going to attach to the end of this, and I'm going to use it to evacuate this tube of all the air that is in it. So, that is the sound of the vacuum tube emptying air out of the container. This is the sound of science. Listen to it happening. The sound will become quieter and less frequent as it continues to remove air from the tube. So we can hear the sounds getting pretty spread out. That means the container is just about free of any air that's in it. We've just about made this a vacuum. That sounds pretty good. So I'm now going to seal off this tube. And remove the vacuum. And now let's watch as the feather and the penny fall. That penny falls like a brick in the absence of air resistance. They are in fact landing at the same time. This is actually one of the first things that they did on the moon after they landed, because they actually tested whether or not a feather would fall the same way as a heavy weight, since the moon has no air resistance. And then we can listen as I let air back into the tube. And now watch again. Oh, the penny is stuck. There we go. But once again, we can see how air resistance affects the motion of objects. Thank you.